So this is Nafeez. So today we're going to see how we can use JavaScript's inbuilt inherent security features to attack its own security implementations and bypass a few restrictions. Right. So just to check, how many of you here are like JavaScript developers? Have developed web applications using JavaScript? All right. This is how today's agenda is going to look like. We'll start with why JavaScript is all important, and we'll talk specifically about the objects and what the JavaScript standard has to talk about it, the Ecmo Script 5 standards, which came up very recently. And then we'll talk about a certain design pattern, and then we'll take a specific example, a library called OAS CSRF guard, and we'll talk about how to find these kind of vulnerabilities going forward in your penetration testings, or how you can, as a developer, try and fix them. So just setting the expectations, as I said, it's about trying to attack implementations in JavaScript and the OAS CSRF guard story, and again, another thing called DOM clobbering. Has anyone of you heard about DOM clobbering before? All right, so that's good. And this is not about the regular cross-site scripting or what a cross-site request forgery attack or the usual stuff you would hear in a JavaScript security context, which is like do not use global variables and stuff like that. So who am I? I'm, as I said, Nafeez. So I work as a security engineer for Citrix in Bangalore. I have some interest in web and networks, specifically in the client-side part of it. I believe that defending and building secure systems are much harder than attacking, because in the first place you need to attack before you go ahead and defend them or build them properly. And this talk does not represent any of my employer's opinions. Okay, so JavaScript. JavaScript is something which is there everywhere. All the mobile phones that you use, all the devices that we see, as long as you have a browser, it's the only way to script a browser, so it's out there. And it is becoming more relevant as we go forward, right? So do anyone of you know about the mean stack? Heard of the mean stack? Any developers? Right, so mean stack is a complete web application stack where you can build a web application using JavaScript only. So if you have heard about MongoDB, it's the database. It's a NoSQL database which completely works. You interface it using JavaScript. So that's the M in the mean. And Express.js is a Node.js web server written by TJ Hollowaychuk, if you know him. So it's a very famous web server framework in Node.js, which is again based out of JavaScript. And then you have the AngularJS, which is a client-side MVC framework by Google. And then you have the Node.js again, which is the server-side JavaScript platform. That's pretty amazing, right? So you just learn one language and you can write a complete web stack, which is not the case which we used to have before. Yeah, so just a little bit of JavaScript primer. JavaScript is fundamentally a very dynamic language. Everything is loosely typed. It's very flexible. You can do a lot of things which you cannot do in other languages because of the amount of flexibility that it provides to you. You can go a little bit deeper and change the original implementations, which is part of what we'll talk about today, and which is completely object-based. Everything is treated as an object. And of course, functions are first-class citizens in the sense like even functions can also act as a variable, which indeed is an object. So when we talk about objects, we have two different types of them. It's the native objects. So the native objects are the ones which are provided by the JavaScript's specifications itself, right? Something like your primitive types, like the number, array, and even the object. So this object over there is the mother of all objects in JavaScript. So you can inherit everything else from there. For example, this array object, which is a native object, can be inherited from the main object. And then you have something which is the host objects. So this is something which we need to really understand before we try to take a look at how the different JavaScript implementations work. So as it would be very obvious from the name itself, host objects are something which you normally use to interface your JavaScript engine with your platform. For example, most of you would be aware of the V8 JavaScript engine by Google. You interface that with the browser using the DOM host object, and you have a complete JavaScript working environment. You interface the same thing with the V8 engine with lib.io, evented.io, and all that, and you have Node.js, right? So for the browsers, your host objects are the DOM, which is a document object model. And for things like Node.js or other platforms, whatever your JavaScript implementation doesn't give by default, you just implement it using the host object. So for Node.js world, it's going to be the HTTP, DNS, TCP, all these protocols. Okay, so let's shift gears a little bit and try and see Ecmo Script. So Ecmo Script, it's another name for JavaScript. There's been a whole lot of philosophy and historically a lot of political reasons involved behind the names of JavaScript and Ecmo Script. But the standard name, according to the specification, is Ecmo Script. So if you want to implement a JavaScript engine or parser, you basically go and look at the Ecmo Script definitions, right? So currently all the browsers are complying with the Ecmo Script 5 specifications. And Ecmo Script 5 specifications, they gave few additions to how an object would actually be treated, right? So if you have an object, say point, so this in JavaScript world, this is how you define an object. You have a point, and you have A as a property, and its value as 1, B as another property, and value as 2. So if you have an object, how can you tamper-proof it? So one of the additions of Ecmo Script 5 is something known as object.defineProperty. So you can basically take an object and its property and define whatever you want, whatever its getter and setter wants to do. So if you've been using JavaScript for quite some time, you already know about getters and setters. It's pretty famous in JavaScript, shows its power as well. But nowadays you do them using the object.defineProperty as a standard. So this specific function over here tries to have an object point and have its property A, and whenever you call the getter of it, which is to say point.a is the getter of this object, it always returns some value which you define. So even if you set something like point.a is equal to 200, it's whenever you ask for point.a, the getter is always going to return you the always faked value. So again, now how can you lock it down? There is something known as object.prevent extensions. So if you give if you do prevent extensions on an object, it's basically going to make sure that you cannot set another property or add anything, extend something to it. So if you say point.c or point.d and try to set it, it's not going to work. We'll see all these implementations in quite a bit. So object.seal, again, is whatever your object.prevent extensions would do. In addition, you cannot delete something else. So for example, if you have point.a already being defined, you cannot go and say delete point.a, which wouldn't do it, which wouldn't allow you to do it. So, and again, object.freeze is the last one of the Ecmo Script 5 properties that we're going to see today. So object.freeze does everything what object.seal does. In addition, it tries to make sure that you cannot change the property of existing, you cannot change the value of the existing properties, right? So if you have point.a set to some 500, and you cannot allow someone else to change the value. So all these have different use cases depending upon the way you implement your JavaScript client side, for example, in a browser, right? So if you're a jQuery, you would basically go and say, I would define something and I would make sure that it's being frozen, object.freeze of, let's say, array.prototype. And nobody would be able to change that array.prototype implementation, so that throughout the code, your array.prototype is going to remain the same. In a sense, to say, even if you load, let's say, some other library, you have jQuery and some other library loaded again after that, that is not going to redefine what you had from what you had from jQuery, right? So it's a very legitimate use case that you want to use it for. So let's take a look at it, how things go. So let's say we have a point. I'm just going to run through the examples again just to show how it really works. Just bear with me. So we have this point which has the object a and 1. So let's try and say object or define property of, we want to say, I want to do the point and want to redefine the getter of, let's say, the property B, property A. Now it's say something like this. Sorry. Okay, so even though we had points, so whatever you say point dot, let's say point dot A is 33, even if you say point dot A is 4, you're still going to, 44, you're still going to get point dot A as 33. So even though internally your point dot A is defined as something else, you try to set it to something else, you get to make sure that it's redefined to something else. Similarly, you can do it for setters as well. You can change the way something is being set. If someone tries to set a value for something, you can always keep changing that. Right? So again, object.prevent extensions will make sure that you cannot add something. So for example, if this is your point, you cannot make sure, you can make sure that point.c is not being set. So it doesn't, it's now point, now we can do something like object.seal, which if you remember, we can try to add, we can make sure that you cannot delete something. So if you say delete point.b, it's not going to work. Your b is still going to be set. Now just showing you so that, just be clear with it. Most of you would have sometimes already be aware of it and have used it. So is there anyone who have already used this in your programs or are aware of it? Oh, that's great. So, and again, let's see object.freeze for the last time. We can go and say, I want to freeze the point object. So no one can basically change. So my value of point.b is 2. If I say point.b is 44, your point.b still remains the same. Now, there is a fundamental difference between this and the way we saw object.defined property. Defined property changes the value which is being shown to the console, right? Which, when you do a getter, it changes the value. But here, it's not even allowing you to change the value, right? So there is a so the internal implementation of the variable still remains the same in the case of object.freeze, but in the other case, it just getters just change it. Okay, so enough of that. Let's come back to what we've been talking about. So with that being said, let's shift gear again, and we'll just merge these three things and come to where we want to. So the principle of unobtrusive JavaScript. So it's a pretty fancy name, but most of you will be already using this pattern. It's a design pattern on the client side, where you want to say that you don't want to mix your design and your behavior, right? So normally, if you're going to do a on inline event handler, you're going to say button on click equal to alert or something like that. Instead, you would basically say just define the presentation and make your behavior everything inside, which is scriptable. So you just add an event listener, just like this. So you have an event listener on click, which would do the stuff for you. So this is a pretty common standard or design which is being suggested by all developers, even for performance reason, and even the security guys would suggest you that, because imagine one of the biggest problems that have been haunting us for the past decade is cross-site scripting, right? So people have been trying to mitigate this in various different ways, try to bring in different mitigation strategies, encoding libraries, but still developers do make mistakes. So this is one of the design patterns people suggest so that you can reduce such mistakes. How about you have a completely static HTML page, right? And you do your dynamic data over JavaScript, and you need to make sure you filter your data only at the JavaScript level, only on the client side. So that all your stuff is being done, all your dynamic data, which is the root cause of cross-site scripting, is going to come from, unless it's a persistent cross-site scripting, by the way, it's going to come from, your reflected standard vanilla XSS is going to come from it's going to only come from an XHR or JSON request in this case, and you can filter all of them at that level. So again, if you have heard of content security policy, it's basically one of the defense mitigations, against cross-site scripting. One of the main use cases of that is to make sure that you code in such a way and use these standards of doing your client-side code so that you're less vulnerable to cross-site scripting attacks. And this even suggests you that. So why am I talking about all this? Because this principle is something which is used, you just want to do it from a security point of view, and that would cause you problems. I'll come to that. So now we have a change in the tradition. If you have been into performance, you'll be already knowing that you normally cache a JavaScript file and leave the HTML pages alone, right? Now it's going to change. You're going to cache your HTML pages, and you're going to leave alone your JavaScript files because they're going to be dynamic depending upon the current user or the current session. Interesting. Now, with that being said, if you think about security, where do you put your dynamic things or your secret artifacts? So let's think about the problem of cross-site request forgery. Today you implement a website using the principle of unobtrusive JavaScript. Where does your CSRF tokens go? And suppose that your HTML page is going to be static. You would naturally think in a few ways, but it should naturally go into your JavaScript file because that's where your dynamic stuff comes. Well, we'll see how one of the industry standard guys did that. So anyone of you are aware of WASP? Yeah, of course, yeah. Anyone of you are aware of their Java CSRF guard framework? So a lot of Java frameworks Java web applications actually use this framework because of the simplicity and it's the kind of protection that it gives. So it is one of the libraries which is completely compatible with the principle of unobtrusive JavaScript. That is to say, you can separate the code and design easily. So where did they keep their tokens? Just like what we just saw. So this is how their implementation looked like. So you would have a script which say, if you're good.com who's trying to use OS CSR guard, you will say good.com/OS CSR guard. And that code, that script is going to load something like this, depending upon the current user. So if you're logged in as a different session, this token is going to change. So you have a dynamic content getting changed inside a JavaScript file. Now, if you have been into attacking web applications, if you have been thinking about cross-site request forgery or HSS in general, this kind of sounds not so good. You can think that since the scripts can be loaded cross-domain as well, a script from, let's say, cdn.google.com can be loaded into your website, say facebook.com, just a bad example. But yeah, so an attacker could basically load this JavaScript file from a cross-domain website, say bad.com, right? He can reference, inside bad.com, he can reference something like script src equal to good.com/csrfguard/.js. It's going to load. Now, well, and basically the attacker can hijack the token and then it's game over. Your CSRF guard or your CSRF protection is not anymore because an attacker could already read your CSRF token, which is what you use to prevent against the whole situation, right? Now, the authors of OS CSRF guard already talked about this a few years back, right? And they say they have a function inside their JavaScript file which loads. It says, which has a function called isValidDomain of document.domain and if it's a good.com. So the way it loads is if you're using this framework for good.com as the domain, then you have a function which calls, it checks between the current document.domain and your good.com, which is the current website which is trying to protect. Now, let's try to get into the isValidDomain and what it tries to do. Okay, so initially it tries to check whether the current value is the same as a target, which is if good.com is being loaded, if this library is being loaded by good.com itself, then yeah, return true. And that's good. And basically, if it returns true, the if statement becomes true again, and then the injection happens and your CSRF guard works. Now, if they have another case to check for subdomains. So they have a specific property called domain strict or something, which when you turn it off, you can actually load this from subdomains. So you can try to protect x.good.com by just using this, by just loading this from good.com. Get the picture, right? Now, very interestingly, when I was trying to actually go deep into the stack, so you had something called as the current.endswith of this value. So this target value is the value of which your current website is, right? So whenever this returns, if I can make the result return always true, then again, it's the same as, the check is bypassed and it's good. Now, so the current.endswith is actually a custom implementation of the OS others, which is normally done by things like string.prototype. So you can basically prototype any objects in JavaScript and add an implementation to it. So they have actually added an endswith prototype to the string, which most of the modern day browsers do support. So they just add it so that some things like IE doesn't support it, so that it can cover every ground, right? Now, what they do here is they just do a match, and it's just known implementation, and whatever this says, the code is going to believe it. Now, since we have been trying to load this from a cross-domain website, an attacker on his own can have his own implementation of string.prototype.endswith, if you think about it, right? But the problem is his code has to load first, and the CSR of God's code has to load second. Again, there is another problem. If he initiates his own definition of endswith, the definition of CSR of God is going to replace it, right? So that's a belief which the authors had a few years back when they implemented it. But with ECMAScript 5, we had a new feature called object.freeze, right? So just by adding a new security feature, you are actually trying to break something which used to work very well before. So this is the kind of attack which I was talking about. So attacker can have something like override.js, and he can go and say string.prototype.endswith is always going to return true. And you can say object.freeze of string.prototype. And he loads this code, and then he can go and say he loads this code on the top, and then he tries to load the CSR of God framework from the cross-domain website, which is bad.com, by the way. Now, the original implementation of custom string prototype by the author is not going to be replaced, because it returns an error because of the object.freeze which the attacker did. It's quite natural. Then again, it's pretty straightforward. You just inject your own forms and steal the token. So as far as OS CSR of God goes, as long as you can try and bypass the is valid domain check, you're pretty much secure. It's gone. So there have been also other variants of prototype overriding bypasses, but this one specifically is interesting because of the object.freeze functionality. So let's attempt to fix this, right? So there was a fix which actually was being pushed into the CSR of God framework, which uses something known as object.isFrozen. Okay, so as you can guess, object.isFrozen is going to say whether a given object is frozen or not. And this is a native object which is being native property which is given by the ECMAScript 5 definition standard. Okay, so it's not a custom implementation; it goes according to the standard. So we can check if my object is already being redefined. It's being redefined, and if it's frozen already, then I can know that someone has tried to change a given object, which is string.prototype, correct? And we push the fits. Now, the problem is JavaScript is too dynamic that even your object.isFrozen can be spoofed. Okay, so as you can see here, an attacker can always return false for object.isFrozen, right? So let's say that we have an object called string.prototype. String.prototype is an object here. Now let's try and say object.isFrozen of string.prototype. It's going to, of course, return false because no one has tried to freeze it. Let's try and freeze it. Okay, so now if we say object.isFrozen of string.prototype, it's going to return true because it's been redefined. It's been frozen. Okay, so we thought we could believe in this check, but unfortunately, it doesn't work that way. So someone can go and say object.isFrozen and redefine the function. Okay, Okay, now if he goes and if whoever does anything, object that is frozen off, sorry, we need to return it false, I'm sorry. Because we need to say known as frozen it. If someone is going to say object that is frozen off this, even though it's being frozen, it doesn't matter. It just, the problem is, this is a very fundamental object that is frozen. Now, you give a security feature, try to check it, but ultimately that can be overridden as well. Now, again, that's the power of JavaScript, but that can be very well used in a lot of other cases as well for the good. If you can use this to detect a lot of things. Hook, do some aspect-oriented programming kind of stuff with JavaScript. But if you're going to try and do that in your definition itself, like in your something like a security feature, and it's going to be pretty bad. So that's just, you can do an object that is frozen, you can redefine it, so the attacker just has to add object that is frozen and return it false always, and the check is always going to be bypassed, and you're still hunky-dory, it still works. Okay, so now let's try and do another way of doing it, right? So we just bypass this using, we need to have the ends width to work, this part to work for this to bypass, right? So we need to have current.ends width this up to this level for this to work. So that means the enable strict, this has to always, the false equal to false always has to match. If the administrator of the OFCSF guard has turned it to off, then it wouldn't even come to this condition, right? So this might not work always. So let's try and go and find a way to completely bypass it. Okay, so we initially saw that the isValid domain is also dependent upon the value of document.domain, okay? So as you can see, the whole security check is, as you can already, I'm pretty sure you guys are already guessing it, but yeah. Document.domain is also a lie, right? You can redefine document.domain and you can make them say anything as you want, right? So something which most of us wouldn't have believed in the first place, because we consider document.domain as a security value which cannot be changed. For example, if you say document.domain equal to blah blah blah, it wouldn't work. But you can actually change object.define property and say document.domain and change stuff just like this, just to make it prove. So here your document.domain is blackhat.com, right? And I can go and say object.define property it's just to show, it just works. Let's take it defcon.com. Oh, wait a second. Define property, document, domain. Yeah. Get function, return. Works, yeah. So now if you say document.domain, now it's going to be defcon.com. So you're actually in the domain of blackhat.com and you're trying to check what is the value of document or domain, and it's your own DOM is trying to fool you, right? Think about the situations in a lot of other scenarios. You're using an analytics library, right? So if an analytics library is trying to check the value of the current domain by using document or domain, the author would have tried to fool the analytics by doing something else. You could always try, instead of a famous website, you could go and have your own website and make it more popular, things like that. So what does that mean? That means that the same technique can be used, and instead of freezing and going with all those hard things, you can just say object.define property of document or domain and whatever the domain you want to bypass, and it's game over. And it's a complete bypass of that. Now, this is not a problem just for CSRF Guard. Of course, it's a bad idea that they try to embed their CSRF tokens inside a JavaScript file, which can be loaded cross-domain. But think of the scenarios where we use document.domain every day just to check what the current value is, right? So how do we deal with this, try to protect this? Well, we try to make sure that do not embed or hard code your tokens inside a JavaScript file, okay? It's pretty hard to protect it as of today. With the current specifications, if we want to have, with the current Ecmo Script 5 specifications in the DOM, if you want to have a secret, precious something in your DOM, and you want to protect it, the only way for you to protect it is by not using it at all. If it's any way you're going to use it, then it's going to be somehow bypassed, and someone can make use of it, right? So you can do something like what most of the websites like GitHub does. You need to have your website's HTML page being non-static, and have something, and you cannot cache them, and you can put them inside your meta tags and try and pass the DOM and walk the DOM and take this stuff. Or the best way is to still have a static website, static page, and in your JavaScript, send a fetch request. Instead of hard coding your secret tokens, just send another request, just like what a pre-flight request does in the modern day course. You can just send another request and fetch the current token from a different endpoint. So that's how we try to fetch CSR of guard as well. So from CSR of guard 3.0, all versions of 3.0 are vulnerable. So from 3.1, we try to do in such a way that we send a post request and try to do it in the second way. You just take the token and populate in your variable. Okay, so any questions so far with the JavaScript's Ecmo Script 5 and all the, yep. Yep. Yes. I was.
Generally, those inputs are right very small, so getting an injection point is not quite challenging.
Yeah. So here we are not talking about a cross-site scripting. Okay, we are talking about someone is having a JS file, and we are talking about same origin policy because JS files can always be loaded cross-domain. So you as an attacker can choose it to put anywhere you want. So you decide the injection point here, right? So you do your injection scripts, you do your overriding scripts, and then load the JavaScript file. Generally, it's naturally a bad idea to have something secret in a publicly accessible JS file, because it can be loaded cross-domain. That's obvious. And this is kind of reminiscent to the JavaScript hijacking attacks, the array.prototype attacks that we had previously. If you have heard about JSON hijacking before, it's something similar to that, but from a different perspective that we use Ecmo Script 5 as well, to come into the party and have some fun. Yeah. So, okay, so DOM clobbering. This is not a completely new thing, and this is the last topic that we're going to talk about today. It's pretty funny as well. So if you haven't heard this before, this has been being talked about for quite a while, and a few people even talk about in Twitter, come up with new DOM clobbering techniques to bypass a whole lot of stuff. So basically what it means is the way the browsers implement the DOM is to always help the developers, okay? So they do a very nasty stuff, which is you try to populate your JavaScript variables depending upon what your form properties have. So if you can have something like form name is equal to hello, and you have a node called input type is equal to text and name is world, then in your JavaScript environment, if you go and say hello.world, it would actually reference to the input node. So if you have been developing, you know this stuff. But that's actually pretty nasty. The supposed way you should have been accessing this is basically say have an ID or parse a DOM and try to reach form, and then try to take that node and then parse it again and take it. But rather you just have a hello.world, a form name dot a child name will give you that. So that can lead to pretty bad stuff. So we're going to just see one ironic example here of how bad this can be. So you would have heard about JavaScript frame busters before. So JavaScript frame busters are just a funny little script which is very ineffective against everything else what it's trying to protect, which says that top.location is equal to self.location. Okay, so when you're trying to iframe something, so this JavaScript frame busters, if you already didn't know, it's just trying to bust out of a current iframe. Okay, if you iframe some website, that is my website, then you can have a code like this, which would bust you out of it. To say the top is the parent window and the self is your current window. If both of them doesn't match, that means you have been put inside someone else, some other container, right? A child. So that means I need to bust out of it. So you say top.location is equal to self.location. Now, this is used to prevent UI reducing attacks, but people bypass it in a lot of ways. They use iframe sandboxing techniques. There's a 204 content technique. I'm not going to talk about that. That itself is funny, but here's something more funny. So people who still use the better way, which is H-frame options, right? To prevent something from being iframed, you use a response header called H-frame options. Now, what can happen here is some people try to be a little bit more paranoid, and they say, you know what, I'll just go and use both, because for some time some browsers didn't use to support H-frame options. Then your stupid frame busting code used to be the second line of defense, which is as good as it's not there, right? So the thing is, would you even imagine that you can cause XSS with a frame busting script? So some of the filters normally allow you to basically inject HTML forms, but not scripts. Okay, if you go and if you have a website which is being protected by a standard WAF, and you have a code like this, which is this, and you can basically have cross-site scripting with it. So what an attacker can do is have a form with a name as self, and location is JavaScript :alert of phone. As you know, JavaScript :alert of phone in your address bar is going to pop out JavaScript, right? So, and you just iframe it, okay? And what happens is, if top not equal to self, your top.location will become a self.location. So because of DOM clobbering, your self.location's value according to the JavaScript environment is actually JavaScript :alert of one, which has replaced the the self.location value, right? Pretty interesting. So it's kind of very bad to see that you can actually have a cross-site scripting just by using just by trying to defend with some other piece of JavaScript code. So this is actually part of work done by Gareth Hayes, if anyone of you already know him. So he calls the DOM as a mess because of the fact that DOMs can be clobbered. And he talks about various other funny techniques about how you can clobber the DOM and do a lot of other stuff. Another thing which I haven't mentioned here as part of the slides, but I would like to tell you is you can do DOM clobbering on a lot of other things as well, right? Think about post message. If you want post message at origin, right? And if you're in a different post message at origin, all these things are like very security sensitive. In Chrome, if you can try a certain variant of DOM clobbering, if you can control the name of the iframe variables, which is the properties on an iframe, you can basically change the way post messages behave in Chrome. So a lot of other stuffs. So with that being said, how do we hunt down these kind of things, especially the things which we talked about? How did I find that even document.domain can be spoofed? How do we go about it? Okay, so there is something called as object.getOwnProperty descriptor. Okay, so object.property descriptor is going to tell you, it's again an Ecmo Script 5 specification. It's going to tell you what the current object's descriptor is like. What's the configurability? Was it writable? Was it being frozen? Things like that. So we can try and see the object.getOwnProperty descriptor of, let's say, document.domain, for instance. And the important thing to note here is the configurability property of that. So Chrome, Firefox, and even IE tries to set this to true, except Safari. So among the modern day browsers, only Safari sets this to false. So that means any property which you think is sensitive for your program, for your code, if it's going to have a configurable value of true, then it's going to be pretty tricky. You cannot believe your own DOM for those values. Okay, so that means let's try something else. How about location.href? Sorry. So the location.href, the configurability is false, which means you can always believe location.href. Someone cannot spoof the value of location.href and give it to you. How about a very specific thing which is specific to Chrome? So Chrome has something known as document.location.origin, which gives you the current origin. Origin itself is it's out there for a security reason, right? Now the configurability of document.location.origin is true, which means you cannot believe the value of location.origin. Pretty bad. It's the browser vendors, they just implement it, just out there sporadically. I don't know what's happening. We just tried to discuss this in the W3C mailing list, and they had different browsers have different philosophies of whether they should try and protect this or not. Because the problem is the developers are always believing these values, and the browsers can simply go ahead and just make the configurability of these to false, but they're just not willing to do that. So this is how Chrome looked like. So can you see that? So all those things which are on the red can be spoofed. So anything like protocol.host.hostname, everything can be spoofed. You're not supposed to believe that. So only thing which you can use to know your current location is window.location.href, right? Now that is again funny because so let's say that today I ask you to tell you that okay, you have a script and you're going to load this from a cross-domain website. You need to make sure that you exactly know what your current domain is. So you know that you're going to write a script which has location.href rather than anything else, because I want to, you already know document.domain and everything else can be spoofed. Now, the problem is, even if you have that in mind, you need to parse it very carefully. You need to go according to the URI specifications. You need to make sure that, because your location.href is going to give a long URL, everything from your scheme protocol up until the hash for the URL location. Now, you need to properly parse them. If you're just going to make a string match, attacker can have good.com and still have a hash of bad.com and take over you. So the web and security sensitive features are evolving in a way so that we cannot even develop very securely, right? So this is one very good example. And again, if you're trying to fuzz different properties in your pen tests or your research, you can do them accordingly using the object.getOnProperty descriptor. And yeah, so again, if these guys talk a lot about all of these stuffs more than I do actually. So Mario, Gerathes, Yosuke Hasegawa, so any one of you actually know these guys? Yeah, that's great. So if you just go to Twitter, just follow these guys and just try to understand what they're trying to say, you'll actually learn a lot and do a lot of stuff with it. And yeah, so these are the things I wanted to share today. Any questions? Okay. All right then. So thank you. Thanks for being here.